Let's go ahead and work on problem homework exercise number 1 from section 5.6. Use the properties of exponents to simplify the given expression. First, express the answer in exponential form, then evaluate. All right, 2 to the third power times 2 to the fourth. Notice, 2 to the third power means 2 times itself 3 times. 2 to the fourth power means 2 times itself 4 times. So notice here, we have 3 2's and 4 2's, so altogether we have 7, right? So again, it would be 2 raised to the 7th power. So the rule is you can simply add the exponents. So if it was like 2 to the 4th power times 2 to the 9th power, it would be 2 to the 13th power as long as the bases are the same. So when you're multiplying, bases are the same, you add the exponents, 3 plus 4, to get the answer, and you copy down the same base, and then you add the exponents. So in this case, it would be 2 to the 7th power. Okay, put into 2, go to the course menu bar. The superscript is the second one, second from the top left, and then the 7, and hit enter, and it's correct. Now evaluate 2 to the third times 2 to the fourth. You know it is 2 to the 7th, right? So go to the calculator, 2. The exponent key is below the clear, the up arrow, but below the clear. So hit that. It superscripts it on the 84. On the TI-83, you'll just get a up arrow, but you just put in a 7 either way. Hit enter, and 2 times itself 7 times is 128. Okay, 3 times 1 times 3 cubed. Remember now, 3 to the first power, 3 times 3 cubed, that is really to the first power, right? So same base, multiplying, add the exponent. 1 plus 3 is 4. So our answer is 3 to the 4th power. Three, superscript to the left, 1 down, or 2 down, 3 to the 4th power. Evaluate, we can do 3 on the calculator, up arrow for exponent, 4. To get an exponent, 4 is the exponent, 3 times itself 4 times is 81. Okay, when you have an exponent to an exponent, in this case, even though when they're written next to each other, it means it is an exponent to an exponent. So it's 3 squared, and then this is cubed. Sometimes I tend to write the second exponent bigger. Now notice, or not bigger, but higher. 3 squared is 3 times 3, right? That's what 3 squared is. How many of these 3 squareds do you have? 3 of them, right? So you have 1 of them, 2 of them, and there's a third one. So notice, you would have 3 times itself, 2, 4, 6 times, so it would be 3 to the 6th power. So 2 in each 3 groups, so you would multiply, right? So if you had 3 to the 5th power raised to the 4th power, 5 times 4, you would have 3 to the 20th, right? 5 in each group, 4 groups, so you would have 3 to the 20th power. In this case, 3 squared to the 3rd power would give you 3 to the 6th power. Three, superscript 6, 3 to the 6th on the calculator, 3 up arrow, 6 for the exponent. 3 times itself 6 times is 729. Okay, what you're dividing, you're going to subtract the exponents. Notice, and the reason 4 to the 8th power is, if we think about 4 to the 8th, it's 4 times itself 8 times, right? What's in the denominator? 4 times itself 6 times. Every 4 over 4 is 1. We can cancel, 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 right? We cancel 6 of them. What's left? 2 of them, right? So it's 4 squared. So notice, you're going to find out how many left, so you're going to subtract. So 4 to the 8th divided by 4 to the 6th, as long as the base is the same, 8 minus 6 gives us 4 squared. Okay? So same base. If you have dividing, you're going to subtract the exponents. So let's go ahead and put that in. 4 superscript 2, and 4 squared we know is what? 4 to the second power. We can probably do that in our head, right? 4 times 4 is 16. And that indeed is the correct answer. Okay, 3 to the 8th divided by 3 to the 6th, you're subtracting the exponents, right? So 8 minus 6 would be 3, similar problem we just did, 3 to the second. I guess the exponents were the same, right? So then 3 squared we know is 3 times 3, which is 9 when we compute it. Any number to the 0 power is 1. Most people just memorize that. 12 to the 0 is 1. 100 to the 0 is 1. 0 to the 0 is 1. So again, actually you can do it on your calculator. 12 raised to the 0 power is equal to 1. Okay? So any number to the 0 power is equal to 1. Most people just tend to memorize that. Number 7. All right, again, any number to the 0 power as long as the base is negative 13, right? In parentheses, it's going to be 0. On the calculator, you need to put in a negative 13 in parentheses. I'll show you why in a minute. Sorry, forgot the 3. To indicate it's a negative base, raised to the 0 power, and we get 1. So again, as long as the base is negative, you get 1 also. Now, this is why we had to put in parentheses. This problem is different from the one we just did. This is the opposite of 10 to the 0 power. Notice the negative, it's not negative 10 to the 0 power. It's not written like that. The negative is out in front, so the base is really 10. So it's 10 to the 0 power is 1. The opposite of a number is like multiplying by negative 1. So negative 1 times 1 is a negative 1. Okay? But if it was, the original problem was negative 10 to the 0, any number to the 0 power is 1 because the base, the negative is part of the base, making it 10, negative 10 here. Here the base is 10, and then the opposite is like multiplying by negative 1. So 10 to the 0 power is 1. Negative 1 times 1 is negative 1. Okay, so be careful. That's probably the most confusing concept in this section. The calculator will do it correctly. Now notice, what did we say? We said the correct answer is a negative 1, which is correct. Now notice, if we just put in the opposite, you got to use the negative sign, and the 10, you can put it next to each other. Sorry, not, I put in a 10, and then raise to the 0 power, and it should be a negative 1, right? Because, see, it was 10 to the 0. If we would have done, if the base was negative 10, then the parentheses around negative 10, and then raise to the 0 power, this is like the negative 13, then that's equal to 1. So as long as you copy it in correctly into the calculator, you'll get the correct answer. So that's good. You can still do these on your calculator. 3 to the negative 3. Now, okay, the definition of a negative exponent is not a negative number. It's the reciprocal, which means you move it to the numerator, from the numerator to the denominator. So 3 to the negative 3 means it's 1 over. You keep the same base, and when you move it into the denominator, which is taking the reciprocal, the exponent becomes negative to positive. So it's 1 over 3 cubed. They want a simplified fraction, and 3 cubed is now just 3 times 3 times 3 because it's a regular exponent. 3 times 3 times 3 is 9 times 3 is 27, okay? So again, 5 to the negative 2. The exponent is negative. It's 1 over 5 squared. 5 squared is 5 times 5, so it's 1 over 25. Notice the answers are positive. They're not negative, okay? The answer, you go from a from the numerator to the denominator with a positive exponent. Numerator to denominator with a positive exponent. Okay, so 3 to the negative 3 is 1 over 27. Okay, the fraction 1 Number 10, 8 to the negative 3. Again, that would be what? 1 over 8 cubed. 8 to the negative 3 would be, again, the reciprocal, right? Negative exponent 1 over 8 cubed. 1 over 8 times 8 times 8. 64 times 8, I believe, is 512, all right? Actually, you can do this on your calculator because it's a number, it's not a variable. So again, let's put this in 1 over 512. Again, it's a reciprocal, it's a positive number. And notice you can do 8, the exponent, it's a negative 3, hit enter, you get a decimal, and then go to the math key. Oh, okay, actually you haven't had fractions yet. Oh yeah, you have, that's right. Remember fractions from section 5.3? Math key and fractions is highlighted, so you hit enter once and then a second time, and you get your answer 1 over 512. Okay? So the previous problem, 3 to the negative 3, and then you do math, hit enter twice, fraction, and remember it was 1 over 27. Okay, 5 to the 4th times 5 to the negative 1. The base is the same, you're multiplying, so what do? You add the exponents. It will work for negative exponents. So 5 to the negative 1, 5 to the 4 plus negative 1, sorry, that should be a negative 1, is equal to 5 to the 3rd power. Some people turn it into a positive exponent. 5 to the negative 1, remember, is 1 over 5 to the 1st, right? Goes down to the denominator. And then the same base, when you're dividing, you subtract the exponents. So 4 minus 1 is 5 to the 3rd. So you can get the same correct answer by doing it that way. Again, exponential with positive exponents. So the answer is, the base is 5. Choose the exponent superscript, second one down from the right, on the left, and it's to the 3rd power. And there's our answer. And then evaluate 5 to the 3rd power is 125. 7 to the negative 6 times 7 to the 1st. Again, remember 7 is 7 to the 1st. So negative 6 plus 1. So 7 to the negative 6 times 7 to the 1st is 7 to the negative 5, right? Negative 6 plus 1. So we're going to go ahead now, again, a fraction. So we can do it on our calculator. If we do 7 to the negative 5th, and then hit, now that's an exponential form, which we're going to cover in a minute. If we go to math, fraction, I don't think it's going to recognize it because it's too small. So an alternative would be, you know the answer 7 to the negative 5th, right? So it's 1 over 7 to the 5th is the denominator. So simply just go ahead and do 7 to the 5th power, right? Because it's 1 over, which is 16,807, right? So see, what I'm doing is, you did 7 to the negative 6 times 7 to the 1st is 7 to the negative 5th, which is 1 over 7 to the 5th. 7 to the 5th is 1 over 16,807. So we can do it that way. Okay, so we can still get our answer using our calculator. So that's good news. So we'll go ahead and put in 1 over 16,807, and that is the correct answer. We're going to stop this session right here. Thank you.